In this short video, I'm going to be describing how to simplify fractions and also how to use that skill to cross-cancel when multiplying fractions. When you see a fraction and you are looking to try to simplify it, what you're really trying to do is make both the numerator and the denominator smaller numbers. We're trying to reduce those numbers to make them easier to work with. The first thing I do when I'm looking at a fraction is I look to see if the numerator and the denominator are both even numbers. If both of them are even numbers, then I know I could start immediately by using a divisor of 2, because 2 goes into every even number. So I could easily divide the top and bottom number here by 2. And my new numerator would be 3. And my new denominator would be 9. Because I just went with 2, because I knew they were even numbers, I knew I could divide both the top and bottom by 2, but I didn't spend a lot of time trying to find the largest possible divisor. I just chose 2 because they were even. Since I did that, I need to ask whether or not I could continue to simplify again. So I have to look at my fraction 3/9 and see if there is a number or divisor that I could use that would go into both 3 and 9. A great trick, the second trick I would use after looking for even numbers, is to take a look at your numerator, which is usually the smallest number unless the fraction is improper. Your numerator, if that can go into your denominator, should be the number you use as your divisor. It will always be the best divisor you could use if it's possible to use it. And in this case, it is possible. We can always divide the numerator by itself. We, in this case, can also divide the denominator by 3, and our numerator will become 1 and our denominator will become 3. And if you can see that if you use the numerator as your divisor, you'll always end up with a numerator of 1 in your final answer. Once you have a numerator of 1, then you know that you're simplified because you can't reduce 1 any further. If we take a look at the two divisors we used, we'll see something interesting. We used 2 and 3. If we multiply the two divisors we used, we'll get 6. What this tells us is that 6 was the very best divisor we could have used. If we'd used 6 the first time, then we would have been simplified in one step. We didn't use 6, but I should have taken a look at 6 to see if it could be used. I'll use it now and show you that again I'm using the numerator as my divisor, which doesn't always work, but it's something you should look at, because if it does work, you know that your new numerator will be a 1, which means that you'll be simplified, and your bottom denominator here will become a 3, and you can see that we would have gotten to 1/3 in one less step by using the largest possible divisor. Now that we know how to simplify, we're going to use that same skill to try to reduce our two factors. These fractions here are called factors, and our answer is, of course, called a product. So what we want to do first is we could take a look first at our fractions and make sure that they are already simplified. We can always simplify our fractions before we multiply. That would be the wise thing to do. Usually they will already be simplified. So the next step would be to cross-cancel. And cross-cancel is called cross-canceling. Really should be called crisscross canceling, because that's what we're doing. We're crisscrossing. We're going to do the same thing that we do when we simplify, but we're going to do it in a crisscross fashion. So I'm going to look at my 6 and my 8, and I'm going to ask myself if there is a divisor that will go into both of them. And I use the same technique. I first look for even numbers, and if they're even, I can get started right away by dividing by 2. And when I do that, I cross out each number and I divide it by 2. 6 divided by 2 is 3, and I replace it with that 3. 8 divided by 2 is 4, and I replace that 8 with a 4. These are my new numbers. My new factors are now 3/4 and 3/27. I may not be done with these two numbers, 3 and 4. I can ask myself again if there's a way to reduce these even further. In this case, there isn't. 3 and 4 cannot be reduced any further. So I'm going to move on to the other two factors, My numerator and my denominator over here are crisscross from each other. So I can now try to find a divisor that goes into 3 and 27. And I use the same techniques again. Neither of these numbers are even, so I know 2 will not work. But my second trick here is to take a look at my smallest number, which is a 3, and see if 3 will go into both. And if it does, then I know that I've used the largest possible divisor. The 3 will go into both of these numbers. So I will divide 3 by 3 and get 1, and 27 divided by 3 to get 9. And because I use 3 and my numerator is 1, I know there's nothing more I can do. I can now take another look at my factors, 1/4, and see if these could be simplified, but they can't because the numerator is 1. And I look at my new factor over here and I have 3 and 9. And 3 and 9 could be simplified. I'm not cross-canceling, I'm just simplifying. But there is a divisor that goes into both 3 and 9, and that would be 3. 3 goes into 3 one time, and 3 goes into 9 3 times. So I was able to cross-cancel, and then after I finished cross-canceling, I was able to simplify one of my factors even more. Why would you want to do all this work? Why not just multiply 6 times 3 and get 18 and 8 times 27? Well, I personally don't want to deal with numbers as large as 27 if I don't have to. But more importantly, when I'm finished cross-canceling and doing all this work here, what I'm left with are much smaller numbers, easier to work with, and likely, if I did a good job of it, I won't have to simplify my answer. 1 times 1 is 1, 4 times 3 is 12. 1/12 cannot be simplified, so therefore I'm finished. If I hadn't done the cross-canceling or the simplifying, I would have had to multiply 3 times 6 to get 18, and 8 times 27 to get 216. Now, if I had not done any of that work and I had 18 over 216, I would have a big chore ahead of me. Trying to simplify that would be no easy task. Much simpler to do the division when the numbers are smaller.